So, my name is Johan Casselgren, and I'm associate professor at Luleå University of Technology on a subject called experimental mechanics. And we have our own snow project up in Luleå, which is called Snow Academy, which is founded by European Union, Sparbanken and Region Norrbotten. And then we have, as said, we have these 4 different vehicle test tracks manufacturer or preparation. They actually prepared the test tracks that the car industry is doing tire testing and vehicle testing on. So that's what I'm going to talk about mainly today, what we are doing against these tire and vehicle testing entrepreneurs and their test tracks. And as you know, snow quality and snow mechanics are, of course, coupled together. And what we are looking for is more or less measurement techniques to actually measure the snow grain size, the snow shape, the density, sometimes the specific surface area, and of course the liquid water content, or how the temperature actually changed the snow mechanics. And I really like this image, which is quite nice to explain what we are doing. This is actually 2 different snow types. This one is fresh snow, and this is spring snow or old, quite spherical snow. And this is actually taken with the same camera and the same illumination. The only thing we have changed is the snow. And here you can see that we get different reflections from the different snow types. So as we come from developing road condition sensors with optical techniques, we actually realized, well, we can use these optical techniques also to differ between different snow types. And of course, then we also have microscopic images that we also use to verify our different measuring methods. And as I've been talking about before, we actually managed to, with the help from NTNU here in Trondheim, in their lab, we actually managed to see that we can actually get different reflections. You have on the axis, you have 3 different wavelengths of light, and we can see that we get actually different reflections from these different types of snow, grain size and grain shapes. But of course, this is in the laboratory where we actually had to do manual. We actually changed the angles manually, so we actually did angular and specular resolved measurements. But it was quite time consuming. So we tried this outdoors and in the field, but that took too long time, so we didn't actually manage to do it to get really good results. So then we actually developed this that we call the dome, which is more or less 9 different, these small is 9 different photodiodes, and then we have 3 laser diodes shining down in the dome, and then we can do a measurement instead in just a couple of seconds. What we are now doing is that we have developed this and are now testing this, and we get quite nice results. We can see that we get different reflectance response from different snow types, but at this time we have quite much manual sorting and such things of the data. So we are now trying to develop a more automatic algorithm so we can actually do the measurement and then get the results more or less at the same time. So right now it's quite a lot of manual work to get these results. But from these measurements we're also seeing that if we just use these backscattering measurements in these angles, we can actually use the road condition sensor that we have been working with quite a lot, which is also based on an optical technique where we use a photodiode and 3 lasers. But with this technique, we can actually do measurements continuously on the test tracks for the vehicle and tire testing. And here is a result that we produced last spring, but this is quite interesting as well. When you do tire testing, the important thing is that you do it on the same, that the surface doesn't change, because then you don't know if it's the tire or if it's the surface that had changed. So we tried to see, can we actually see if we drive in the same path as been driven before, or are we in the new freshly prepared snow. And here you can see the result from the optical sensor, which is a ratio between two of the wavelengths, laser wavelengths. And we had the question here was also, we did some tests on outdoor test tracks, and then up in PTO we actually have a big indoor facility with 10,000 square meter indoor test tracks. So we wanted to see, well, is there any difference on the indoor snow or the outside snow? So what we did was that we drove in 3 lanes. In the first lane we drove 3 times and braked, and then we braked in 2 different lanes to the right of this first lane. And here you can see the first lane, and then you can see how actually the signal decreases when we do the braking in the same track. And then we change to a different track to the right, and then we get almost the same response that we did for the first, which indicates that we can actually see that here is fresh snow, untouched, and then we brake, and then we get a decline in the response for the 2 seconds when we brake in the same track, and then we get the same response as the first. And we get more or less the same in the indoor flex, that the reflection actually decreases, except for this one. And this is quite nice, actually. It's a mistake, but after going through my measurement, I realized I actually drove 1 more time in the first track. So here we can actually see that the system is actually showing us that, well, here you did drive on already used snow, so the system seems to work quite well in that sense. And here you have the braking friction, which was quite interesting to see, because that was also something that we discussed. Is the friction different from the indoor, where you have a lot, not that humid air, it's very dry, the air indoor, and is it different from the outdoor, even though we have almost the same temperature? But the answer is that the friction is quite similar, I would say. It goes around from 0.25 up to, we have this outlier, but up to 0.35 in almost every case. So that was quite nice experiments that show that we can actually say something about the track quality, more or less, or the snow quality on the tracks. But those measurements are focusing on the top layer of the surface. This is actually a setup that I got last Friday. So this is really fresh measurements from last Saturday, where I dug a hole outside in my own backyard. And here we use the same optical sensor. You can see it's a little older model, but it's the same with 3 laser diodes and a photodetector. And the idea is to actually measure the snow cut here with the optical sensor. And this is just the same ratio as in the previous picture. And here we get 2 peaks. This is just 2 measurements of the same, 2 repetitions. But we get 2 peaks here. And that is quite interesting, because we have had 2 warm periods in Luleå during this. And now it's really hard to see. But when I looked at it, I actually realized that there were 2 layers with quite a larger snow grains because of the heat, that they have actually melted together and started to grow. So this seems quite promising as well, that we can actually see this in the snow cut as well. So, but this is something that we will try to develop even more now, as it was finished last Friday. So that is actually something that we focus on the depth of the snow as well. Then we actually have another project which is also incorporated in the Snow Academy project, but this together with Volvo, which have of course problems with, as the vehicles get more and more sensors. When the car looks like this, it's problems for those sensors. So they are really interested in how the adhesion snow gets stuck on the vehicle. And here we actually have used the method that we called angle of repose, or it's called angle of repose, to actually try to see how the snow adhesion changes with temperature. And the angle of repose is more or less the angle you get of this snow cone when you more or less shiv it through a filter and then let it fall on this cone. And from last year, we actually got some results where we could see that the angle of repose actually increases with increased temperature. So this is something that we also are carrying out this winter to see get even better measurements for this angle of repose. And then the last thing that we are doing right now is outdoors is together with BRP, the snowmobile manufacturer, which has developed a shear force. That should actually move. A shear force measurement. Now this is actually after the measurement, but the idea is to put these blades down into the snow and then measure actually the torque that is needed to rotate them while we measure the angle. So we get, from that we can actually calculate the shear force of the snow. And this is of course for the snowmobile to actually be able to model the snow tracks better. And together with that we also do pressure measurement, and here you can actually see it's quite mobile, this system, so we can actually mount it on a snowmobile and actually take it out in the field where we can do measurements wherever we want. But we also have a pressure measurements where we can increase the pressure and measure the distance, how far it actually has sunken in. And here you can see in this example, you can see how the snow actually has layers where we get some dips when we break through these layers. So this combined with the shear force, we hope to actually be able to model the snow track on the snowmobiles and how they can actually be developed even better for better framkomlighet in English, Swedish. So they can actually go better in the deep snow. This is more or less the focus we have on the outdoor measurements. Then we are, of course, continuing our modeling of this snow as we have the microtomography system. We actually, all the measurements we are doing outside, we are trying to actually take into and test in the microtomography system, which is a X-ray system, and the brighter spots here you can actually, is the snow, different snow particles. So we are also planning some experiments there where we push push this snow and see how that actually compacts as well, and try to do some shear experiments in the microtomography system as well. But as a last plan, we actually now we have all these different measuring methods. So the plan for March now is actually to take them all more or less to 4 different test tracks and do all of the measurements at the same spot, so we get more or less all measurements, because before we have done some measurements there, but now we will try to actually do all measurements at the same time, so we can get a lot of information from the snow. So we will try to do almost every of these measurements at the same time, at the same place. So that's the plan for March. So we have quite a lot of hectic March in front of us, I would say. So thank you for that, and that was everything I wanted to present today.